Okay, geometry fans, our topic for today, this is notes 8-6. This is called the law of sines. And this is an introduction into some higher level trigonometry. This is something you may not see until an Algebra 3 course or possibly even a pre-calculus course. So you might see it in geometry, maybe not so much, but I'm going to present it to you. So our objectives after this lesson, students should be able to use the law of sines to solve triangles. Before we begin, let me give you your joke of the day. If I had to rate the solar system, I would give it 1 star. 1 star of the sun. Up until this point, I have told you that the only time we can use sine, cosine, and tangent is when we have a right triangle. However, that is not necessarily true. If I take a triangle, and I'll call this A, B, and C. Let's say that this is not a right triangle, all right? And so opposite angle A, I'm gonna label that side little a. Opposite angle B, I'll label that side little b. Opposite angle C, I will label that angle C. Now, this is not a right triangle. However, I could make a right triangle by dropping an altitude here. And so what I would do is I would create 2 right triangles. This is the height, so I'll label that with an H. Now if I wanted to use sine, in this right triangle, the sine of angle A would be equal to the opposite, which is H, divided by the hypotenuse, which is B, if I'm using SOHCAHTOA. If I wanted to use the other right triangle, this one, I could say the sine of angle B, sine is the opposite divided by the hypotenuse, the opposite length is H, divided by the hypotenuse, which is A. Okay, now this gives us 2 equations. But one thing I could do in both of these equations, I could solve for H. So in other words, if I wanted to move the B to the other side so that I'd have H by itself, I could multiply here by B, and I would get B times the sine of A, angle A, is equal to H. And then over here, I would do the same thing, except I would multiply by A, that length, and we would get A times the sine of angle B is also equal to H. Now what happens is we have 2 expressions that are equal to the same thing. Therefore, by the transitive property or the substitution property, they have to be equal to each other. So I could say B times the sine of A is equal to A times the sine of angle B. Remember that it's always the sine, the cosine, the tangent. These are angle measures here. So the lowercase letters represent sides. Okay, so B is a side, A is a side, C is a side, and the capital letters represent angles. Now I'll show you a different way of writing angle measure in a moment. Now I'm going to do one more thing with this equation. I'm going to move the length B to this side, and I can do that since this is multiplication. To undo that, I can divide by B. And at the same time, let me move the A to the left side. So to undo that, I would divide both sides by A. And so what we end up getting here, the B's will cancel out here, the A's will cancel out, they divide to 1 here. And what we get is the sine of angle A divided by the length of its opposite side is equal to the sine of angle B divided by the length of its opposite side. And we could extend this to say that the sine of angle C divided by its opposite length C, these are always true. This is called the law of sines. And the nice thing about this is that this is true whether the triangle is a right triangle or not. It doesn't have to be a right triangle. So this is going to give us a couple of more options. Now, situations when you can use the law of sines what we basically do here is we make a proportion. So let's say I'm using the first two terms here, the first two ratios for my proportion. Notice that you have 4 values in a proportion. We have 2 angle measures and we have 2 side lengths, and whatever angle we're using, it is the opposite length that goes in the denominator. So if we're using angle B, then the bottom length here is B. If we're using angle A, then the side underneath it, that is side A. So to solve a proportion, we need to know 3 of these things. So we could know 2 sides and an angle. That's possible. We could know 2 angles and a side length. So specifically, we can do this. One situation would be here. So we would know this angle and its opposite length. So it'd be like these 2 values here. And then we would have one more angle measure, which was this, which would leave this as our variable, the missing piece, which we can solve for. So this is a situation, think back to congruence, angle, angle, side, we can use. We could use angle, side, angle. So if we have A, here's S, and here's A. So the 2 angles and the side beneath. Now, you might be thinking, well, we've got a problem here because not only am I missing, if I wanted to use this angle, the problem is I'm missing this side, and if I'm using this side, I'm also missing this angle. We can't be missing 2 things here. But if we know 2 angles of a triangle, we can always find the 3rd angle because they add up to 180, so then we would know the angle and its opposite side. ASA works. The other situation that actually works is side, side, angle. Now we'll come back to this. So side, side, and then an angle. So we have an angle and its opposite length. That would be like here. And then we would have another length. So the only thing we'd be missing here would be the angle measure for B. Now situations where we would not have enough information would be side, side, side. And the reason is in this, when you do the law of sines, you have 2 angle measures. Well, in this case, we're missing all of the angles. So there's not enough information to use the law of sines, and we also cannot use SAS. Now, what we'll learn in the next lesson is that there's a different rule for side, 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 and there's a different rule for side, angle, side. Okay, so let's do a couple examples. Let me show you how this works, and it's actually pretty simple. Directions: solve the following triangles. To solve a triangle means to find all the missing values. Find the missing angles and the missing sides. Missing angles and sides. Many times, especially as you get into trigonometry and pre-calculus, you stop using capital letters for angles, like angle A, angle B, angle C, and we start using Greek letters. Alpha, beta, gamma, that's A, B, and C. So if you see a Greek letter, alpha, beta, they're referring to angle measures. If you see a lowercase print letter, then we're talking about side length. Okay, now I'm going to draw a triangle. It is probably not going to be accurate, which is fine. Alpha is 45 degrees. Now what that means is that its opposite length is A. Beta, this is beta, is 40 degrees, which means its opposite length is B. Now the length of C is 4. This is a gamma here. That's the letter I'm going to use. So I've got alpha, beta, gamma. Those are my 3 angle measures. And then I have A, B, C. Those are my 3 side lengths. So solve the following triangles. Well, we have 3 pieces here that are missing that we need to find. The easiest one to find first is the missing angle because we already know 2 of them. So we know that if I add 45 and 40 and then subtract that from 180, what we get here is 95 degrees. So there's one piece of this right there. Now, it's your choice whether you want to find A first or if you want to find B first. Let's say we want to go for A. So to find A, and I'm going to use this. So the sine of angle A divided by its opposite length. So we have 45 degrees. That was the angle opposite A. So the sine of 45 degrees divided by its opposite length, which is A, equals. Now I need this ratio here to have two numbers. We need to know those values. So I don't want to use 40 degrees because I'm also missing that opposite length. That would give me another variable. However, I do have 95 degrees, and I do know its opposite length is 4. So I can say the sine of 95 degrees divided by its opposite length, which is positive 4, and now we have a proportion. To solve a proportion, we cross multiply. So A is going to multiply the sine of 95 degrees equals, and then 4 times the sine of 45 degrees. Now you can type these in the calculator. The problem is you're going to get decimals, and we don't want to round until the very end, so I'm going to keep it in this form until I'm ready to type and get my final answer. Now the last thing to do to solve for A, well, this is A times the sine of 95 degrees. I'm going to divide by the sine of 95 degrees, and we get A equals. Now I will go to my calculator. Before I type sine, cosine, tangent, I should always check my mode, make sure that I'm in degree measures, or in degree mode. I am, so that's good. So I'm going to type, and I can make this as a fraction, which is nice. 4 times, you don't even need the times, 4 sine 45 divided by the sine of 95 degrees and equals 2.84. I'm going to round it to the hundredths place. The more places I go to, the more accurate this is going to be. So 2.84. A is 2.84. Now, we're not done here because we still have not found B yet. I do know A. But we can go ahead and find B by basically doing the same thing we just did. Now, if we need to find B, well, that's opposite 40 degrees. So I can make another proportion. I can say the sine of 40 degrees divided by its opposite length, which is B, equals, let's just use this again, the sine of 95 degrees divided by 4. Cross multiply, B times the sine of 95 degrees is equal to 4 times the sine of 40 degrees. And then our last move here is divide by sine of 95 degrees, both sides. And what that leaves us with, this is 1b equals, and now it's a calculator problem, 4 times the sine of 40 divided by the sine of 95. And we get 2.58. So, have we solved the triangle? Well, we found the length of A, we found the length of B, we found the missing angle measure gamma, and so now we have all the values. Okay, so this is 2.58, 2.84, and 95 degrees. And that is the end of part 1.